So welcome everyone to our Planet Watch interviews. We are very excited and very happy to have you here. We started these interviews because we wanted to tell you more about the problems that we are trying to solve, about the air quality, about the pollution that is impacting our lives and our health. And we thought that interviews would be the best way to actually talk to you about this. Having different guests coming from all over the world. And again, we are very happy to have today here Sara Zanni. She's also a collaborator of Planet Watch. She's working with us. She's an environmental engineer. She knows everything about Planet Watch. She knows even more than we do. And we, again, are really happy to welcome her here in this interview live.
Okay.
Sara, you were telling us that you were working in different fields, but your specialty is air quality. Why is air quality so different from all the other aspects that we are now seeing within the environmental engineering, for example? How do we see air pollution? Do we understand it well? Are we aware of how important it is for our health? What do you think?
Well, I think that the big issue in approaching the air quality issue is that you can't see that except in particular conditions. Because if you think about it, the history of the human approach toward the air pollution started with the London smog. So the bad occurrence during cold winter time, when in London they have a particular meteorological condition which forced the fog to stay into the city and it couldn't be washed out by the wind, and the burning of the coal into the households and in these so many deaths, and because there are many concurrent possible causes that make the health of people worse, of course. But when you have a strict correlation between the number of deaths and the concentration of certain pollutants in the air and the long-term exposure of people to particulate matter, for example, so fine that can travel down in your airways and down to your lungs, even entering your blood circulation where the size allows, so below, for example, 1 micron, the particles, even dust particles, so inert particles, can travel into your pulmonary alveolus and deeply affect your health in the medium and long term. So when you have this strict correlation, then okay, as a researcher, because I'm also researcher into University of Bologna, into sustainability management, involved into many sustainability management research groups and industrial transition projects. We used to say that correlation does not prove causation, but it did in this sense, and thanks to many epidemiological studies, so performed by medical researchers, not me. I'm just an engineer, so I wouldn't, go much deeper into the medical aspects. But when you have epidemiological studies supporting this kind of statement, then you have to take it seriously. And I think that people are starting taking this seriously, and policymakers also.
You were mentioning you're working with the University of Bologna. We are also talking about different studies, and I think they were talked about all over the world. One was the study from the University of Harvard, but then this was also a study from the University of Bologna. Can you tell us a little bit more about the study that your colleagues did? And I guess that now we might also connect it a little bit to what we are doing with Planet Watch. and what can every person actually do in order to improve their health and the quality of the air they're breathing.
Okay. Well, during the COVID crisis, several research were published. Their contribution to our understanding of such a, well, I would say such a tragedy, because it's something that we were not prepared to face, not at all. Even though we tried see it coming in a way, but we didn't got prepared enough. I would say that the death toll that we paid demonstrated. But many research groups put a huge effort in starting explaining why this kind of occurrence spread so much in particular regions and not others, which was a good news for the regions we were spared. But of course, this posed many questions about why in the north of Italy the death toll was so high, why so many people got sick in such a very short period, and why we weren't able to contain the spreading this outbreak. My fellow colleague at the University of Bologna, Professor Setti, and his team, in cooperation with other universities in Europe, started tracking the correlation between the COVID spread, so the number of cases, and the concentration of particulate matters in the air into Emilia-Romagna and into other regions, in other surrounding region of the Pope land, finding out there is a positive, unfortunately, correlation between these two aspects. So where you have the highest pollution in terms of particulate matter, there you have the highest number of people infected by the COVID. But what is most important is where you have the most of the very adverse effect and the people getting very sick, going into intensive care units, and people dying because of the COVID or for pathology related to the COVID. So again, correlation does not prove causation, but nevertheless, the correlation was so strong that other research groups started implementing similar studies, and it is a matter of days, I think, that a study from the University of Bergamo and Milan has been published, again, tracing the correlation between particulate matter 2.5, so in the size of 2.5 microns and below, and the number of people getting very sick because of the COVID.
May I interrupt you here? May I interrupt you here? Can you help us understand how small this is? Can we compare it to anything that small that we know?
2.5 is very, very small. It's something of, I would say, part of the diameter of your air.
Okay.
Something very smaller by order of magnitude. So it's something that can travel, something that is not stopped by your high filter, which is the nose, neither the filter that you have in your larynges and in the upper throat, and something that can travel down to your bronchos. So it is supposed not to enter directly the pulmonary alveolus, but it can travel down enough to make remarkable damages. But the fact is that this research group started studying PM 2.5 in terms of carrier for the COVID. So it is like a sponge traveling in the air with many holes in which the virus, unfortunately, can enter, settle, and reproduce it. Well, not really reproduce because they need a host cell, of course. This is why they love so much to uh, to infect people, but at least it can survive if the humidity is at the proper range.
Mm-hmm.
It survives and it can linger in the air for hours. And it's something that has been demonstrated by many research, for example, by the University of Brisbane some years ago, that the smaller the particular is, the longer it lingers in the air,
Okay.
even up to days in normal condition in the indoor environment. And if the virus is able to protect itself into this flying sponge, then of course it is supposed that if you come to breathe this particulate, then you're most likely expected to develop the infection.
Mm-hmm.
It's something that, it's not directly linked. Again, it's something that lies on correlation studies, because it has been demonstrated that you need a high viral number to be infected and to develop the illness, the COVID disease. But nevertheless, coming into contact with the virus many, many times increase your probability of getting sick. So even the air pollution may, again, we don't have, the fil rouge directly tracked, because it's not possible at this stage of development of this kind of studies. But nevertheless, correlation is very high. And this is why we are suggesting in every possible way to, if you think about the anti-COVID measures that are suggested for indoor environment, not too many people into the same environment, open the window as many times as you can, clean the surfaces in order not to let viruses settle and possibly be resuspended. Because in time, all the dust that we have, even in our households, got resuspended by simply by walking on the floor. There are many studies demonstrating that due to the electrical field developed by the walking activity, we are resuspending continuously our dust inside our households. And of course, again, it's a matter. During my activity as a risk assessment analyst, I digested, I make mine the approach of risk assessment analyst, which is even the smallest danger can become a high risk if you are exposed too many times. So if we can take this simple measure to protect ourselves, why don't?
Yeah, I mean, in a way, all the facts that you were talking about are very fascinating to the people that are not environmental engineers, because we don't know about that, we don't study that. But now, unfortunately, also due to this tragedy that we have been living through, we can see that this is very important, and it's important that everyone knows a little bit about this ways of how to protect ourselves. So what is dangerous, what is not dangerous, everything that was connected to bad air quality is kind of like you were explaining it now in very detail, could be connected to COVID. What is your advice to our viewers, to the planet watchers? What can we do in our everyday life? We, as you, I mean, also with your help, of course, we have started writing blogs, writing tips and tricks in order for the readers to understand more, to see how easy it is sometimes to improve the quality of the air you're breathing.
Well, I would say that, of course, when we talk about COVID, I would leave the floor to the medical experts, because they have the deeper knowledge and the understanding on which are the most appropriate measure we have to take to protect from the direct exposure from people to people. And when you talk about environmental exposure, it is the same for COVID, for other disease, but also for long-term effects, like for the possibility to develop emphysema or asthma or so on. So I guess that the smartest way to protect ourselves is to try and conduct a healthy life. So trying to clean our air by opening the window so many times we can, COVID or not COVID. It's a matter of, for example, the cleansing agents that we are using in our offices, households, the disinfectants that we are making huge use of in this period, because we want to have surfaces clean from, again, the risk that we are experiencing. All these cleansing agents are releasing volatile organic compounds, something that in the long term may pose our health at risk, because they are affecting our airways, our lungs, and so on, and in the long term can make us develop some, well, unpleasant disease, I would say. So opening the windows, something that can help you in keeping all these vapors and also pollutants deriving from the furniture, from the coatings of our furniture, or the scented candles that I like to burn in winter time, in Christmas time and so on, typically release not only particulate matter, because they are burning and therefore there are particles developing, but also volatile organic compounds again. So something that can pose a threat to my health. So opening the windows, limiting when possible chemicals we are using to clean our houses, and in time also working environments, preferring the safer detergents. And it's a matter of balance, of course. In these times, we have to have the best disinfection possible of surfaces, especially in working environments. But again, after the disinfection, you can open the window, you can switch the ventilation on and change as many volumes of air you can. In this way, the dispersed emissions can be washed out from the environment and the surfaces remains clean. Again, perform as much outdoor activity as you can, but keeping an eye on the alert proposed by the environmental authority or the health authority. So when there are particularly polluted days where you have steady condition of the atmosphere or thermal inversion into the poor plants, for example, it's better not to perform heavy physical activity. Limit your training outdoor when there are tropospheric zone conditions, very hot temperature, or highly polluted days, for example, in winter time. So it's a matter of gathering knowledge, sharing information. So in this way, again, our tip and tricks are just suggestion, but we can share tip and tricks together with the Planet Watcher and with our community in order to grow an asset of knowledge which is collective, and we can help each other sometimes by simple suggestion and with simple tricks. We can really improve our health and and decrease our exposure to airborne contaminants.
We were discussing, talking a little bit before this interview, and I think that this is also something that Planet Watch really wants to do, to share knowledge, bring something that is, I would say, good enough information that is not, news that might not be true, for example, especially now with COVID, but we have specialists like you and some other people that are helping us understand what is the best information we can give to our users, planet watchers. We also have now beta testers that are testing our app, and we would really like to gather as much information as possible also through the app and sharing this information. So I would say one part is the part that what can you do in your everyday life to actually live better, live healthier. But the other part is how can we gather information from the outside world in order to have a more systematic information about what's happening in a certain region, in a certain city, to also help maybe cities, governments, companies address this issue. Talking about the future, or maybe at least, I don't know, a few months, a few years, what do you think would be the best approach in fighting air pollution? Because I think it should be a collective action.
Well, it's not an easy question because I suppose it's something that even policymakers are wondering about. But well, talking about our everyday life, most of the time it's just a matter of common sense because some strategies that I'm applying now, based on knowledge and on reading many articles and so on, when applied, when rooted down into everyday life, they become simple actions that actually my great grandmother already put in place 30 or 40 or 50 years ago to protect herself against the exposure, for example, to dust or other threats that she already felt as real. But when you step up and try and watch at the bigger picture, it's not so easy because, of course, you have so many different interesting and most of the time conflicting interests in place. And for policymaker, I think that even even a collective effort like the one that we are starting with the Planet Watcher can be of real help because gathering as much information as possible, real scale information taken on the ground, because as you may know, as European Union, we already have in place several strategies for both monitoring and keeping the air quality under control. So the environmental legislation already developed national emission ceiling, which are limiting the amount of certain contaminants that can be emitted at the national level into the whole European Union. And we also have the emission trading scheme and the European pollution and transfer release register, where we keep under control certain categories of air pollutants emitted, for example, by industries, where they are limited into the amount of contaminants, for example, greenhouse gases, that they can emit every year. And this limits, this threshold level of contamination, are lowered down or decreased every year in order to contain the air pollution by the industrial sector and at the same time improve the green solution. So in a way, there is this cap and trade system by which the manufacturing companies and the industry sector in general is pushed towards sustainable transition by legislation, fees, and so on. And plus, as European Union, we developed the Copernicus program, by which we launch a satellites group, which is particularly devoted in gathering environmental data at different levels on the land coverage, water pollution, fire, and so on, but also and particularly air pollution. So we have many data about air pollution at a higher level,
Mm-hmm.
but what is required, it's data from the ground.
Mm-hmm.
And in this way, all these actions, like the ones that we are putting in place as Planet Watch, are more than welcome and can really improve the approach of policymakers toward this kind of issue.
Mm-hmm.
Because again, it's only putting numbers on the table and modeling the kind of impact that you may trigger by taking one policy or another, that you can really understand the kind of approach it's better to take in order to have a certain to reach a certain goal or another.
Mm-hmm.
It's not a matter of saying no,
Mm-hmm.
because sustainability in its very core as not only environment but also society and
Mm-hmm.
economy. Because the answer to no, no, you can do it because we have to protect only the environment would be always okay. And how are we supposed to pay the bills?
Mm-hmm.
And in this sense, it's only the integrated approach that can lead us towards the sustainable transition we need.
Mm-hmm.
Talking about air pollution, but also all other kinds of pollution. In terms of air pollution, of course, there is still a gap of knowledge
Mm-hmm.
that we have to fill. And this is the important task we have to fulfill within months or a few years if we really want to make a difference, both for air pollution, but also, for example, for other challenges that we are facing, like climate change.
Mm-hmm.
We have just a limited time ahead to limit the effects of the climate change. Otherwise, we can only adapt them.
Mm-hmm.
And it's going to be a completely different world for the next generation and our kids.
Of course, unfortunately, if we don't do it
Yeah.
in the right way. But that's very true what you said. And I guess this is also why Planet Watch is now focusing on air quality monitoring, because this is the first step. How can you gather high quality information, information on the part of the city, for example, that is the most important one or most problematic one, because we see now challenges here. The network is not big enough, or we can't get a real time information. And for the last question today, maybe because we're talking about so many different and interesting things, can you tell us a little bit about this issue that is happening also in the cities, and when we talk about canyons, and why maybe having more sensors in one city, in one street, would actually help understanding better what's happening there, because we might not have the right information actually.
Mm-hmm. Well, yeah, the quality on the information we are gathering
Mm.
are crucial. Is crucial, both when we talk about environmental data, but also the information you were asking about the last question.
Mm.
So the reliability of the source of information is crucial to take the right decision. And it's the same when you go reading a news
Mm-hmm.
or taking measurements into into the real into the real world. So the way you monitor the air quality will definitely affect the quality of data you will look at and the quality of decisions you're going to take. The phenomenon you were mentioning, the urban canyon, it's something that it is related to, um, well, in a way, again, the gap of knowledge that was that is present when we develop a town. Well, when we develop an urban environment, we seldomly think about the air quality that people are going to
Mm-hmm.
perceive in that block, in that neighbors along that road. We are only thinking about how many households, how many people, how many cars in that street, what's going to be the car circulation, and what kind of, I don't know, economic activity may I
Mm-hmm.
put there. And in this way, what we built up was the answer for this kind of issue that we pose to us as developer of cities, of towns, and so on. But we never thought about what kind of environment is going to develop inside there. This is why our cities are affected by the heat island effect, for example. It's typical. When I go to Bologna, for example, most of the time my car shows 3 or 4 degrees more than when I come back home and I live in a small town. And it would be more again compared to the countryside, for example, when the night temperature decrease thanks to the nature that I have a different thermal inertia compared to the concrete, the households and the buildings in general. And this is something that we didn't talk about hundreds of years ago when we built our cities. And talking about the air quality and the urban canyon effect, it's something that must be solved into our towns, both in terms of, again, temperature, which is something that is strictly related to the air circulation, and in terms of air quality. But it's not easy because most of the time the devices that we have and the monitoring station, for example, the ones that are controlled by the environmental authority, are few, very precise, returning very precise data, very high quality data, but they are only 3 or 4 or 5 into a city, in a big city. And in this way, you cannot see these kind of effects, and you cannot study them. This is why some research projects focus particularly on this kind of effects. For example, the Escape project, in which participated also University of Bologna, for example. And it's really important to understand the air circulation when you have high buildings at both sides of a road. Most of the time you will have the air entering this canyon from one side, recirculating inside, so accumulating air pollutants. And it's not provided that these air pollutants are washed out by the traffic, for example, due to the pushing effect of the cars, of the lines of cars. And in this way, people, for example, walking along the sidewalks may breathe air which quality is far worse than anywhere else in the city. But of course, the sidewalks are where people are supposed to walk.
Yeah.
So it is something that must be studied, and measure must be taken against this effect. And sometimes, again, all times, proposed the best solution, which was planting trees along the roads that can build up a barrier against this kind of effect. This was just an example, but of course, it's a matter of taking informed decision, for example, for the planning of new neighborhoods. You have to think about that, but you can think about that and make eco-design of new neighborhoods only if you have numbers and if you have knowledge supporting you in this sense.
That's very fascinating. I'm learning more every minute. But unfortunately, our time is running off. So I will thank you so much, Sara, for being with us, for telling us all this interesting.
Really my pleasure.
Yeah.
And I hope that we have more opportunity for exchanges also with the Planet Watcher and people.
Exactly. I think that we can do that. I'm quite certain that we can do that. We'll find a way how to share as much information as possible, and this is one of the ways. So that was our first interview. I think it was very interesting. It was a very good introduction to all the other interviews we're going to have. And thank you very much again, Sara, for being with us.
Thank you.
And thank you for everyone for listening. Unfortunately, we had some problems at the beginning of our streaming. I think, and I'm certain that next time we're going to be and do better.
It was our first time on the stage. I think it is, expectable.
Yeah, of course. I think that we're going to figure out this technology a little bit better. But it was still very interesting. We are going to still write about this interview and share more information. So just stay tuned and have a nice day.
Thank you.
Bye, Sara.